Hey guys, how we doing? We're back in the shop today, and I'm going to get back on that adapter plate I was working on the other day. I ran into some snags with it. I kind of goofed up, and I grabbed a drawing from. I mixed up two drawings, and I mixed up two sets of dimensions, and I didn't catch it. I just kept working with it, and I put all my holes into the plate, and of course, that's the problem that I ran into, and that's the reason that I've got to do it over again. Today I'm going to be showing basically me reworking that same part, and I'm going to use the same piece of steel, and I'm going to use my rotary table. I'm going to throw the rotary table on the mill. I've got that piece of plate sitting on there, and I made the alignment shaft that's going to line up the rotary table itself with the adapter plate and to the chuck to keep everything in center. So I'm going to go ahead and rework that plate as I just said, and I'll give you a little look at that right now, and after that we're going to kind of put it on pause for a few minutes, which won't be a few minutes for you on YouTube, and jump into the next step of the process, which is going to be, of course, this rotary plate right here. So let me just adjust this. This is the plate that I was working on right here that I've got to rework today, and this is my alignment shaft that I made to line all three parts up. That's a Morse 3 taper. This right here is inch 230 diameter to match this hole here, and the big end is going to fit down inside the bore of my chuck. So the three diameters, including the taper, are going to line all three parts up, and that's what's going to enable me to use this assembly of parts. Of course, this is a prototype part. I think I said before, I don't think one of these exists. If it does, then I'm not trying to copy it. I'm just using one of my ideas. So that's what I got on hand, and I'm going to go ahead and take my parts, jump back over onto my mill, and we'll see you back here shortly and get some updates. Just brought you back for a minute here. I've been doing a little bit of work off camera. As you can see here, I've got this adapter plate fixed down to the rotary table. Went ahead and made my T-nuts to hold it down into the slots here. I got my alignment shaft in the middle, Morse 3 taper in the bottom, Morse 3 taper in the table. I'm going to go ahead and throw this up over on my mill. Got the table cleaned off, and I'm going to get this thing set up on there, dialed in square, and I'll bring you back once I get that thing all set up, and I'm going to go ahead and get this straightened out. So we'll bring you back in a bit. Real quick, give you a quick view of that. Got the rotary table up on the mill here. Got her set up, locked down. This rotary table here, it's got keys that actually screw onto the bases, and the keys lock down into the slots of the table. It's real sweet. So you'll sit it down in there, the keys fall in your slots, and you go ahead and put your T-nuts or clamp or whatever it is on there, lock your rotary table in place. I got my adapter plate fastened down to the rotary table. It's lined up on dead center with my alignment shaft here. Now I'm going to go ahead and throw my indicator in there, get on center of this thing, and from that point I can get going. Figured I'd give you a quick view of that. I'm not going to bore you with all the setting up and the ridiculous details and all that. So I'll bring back a few minutes when I'm getting to it. And I got her all dialed in. I got my spindle sitting dead center. She's all indicated up. Here, I'll give you a quick peek at that. Now let me try and get this thing into focus. There we go. Alright, so I'm going to spin it. Alright, so I realize it's shaky. I'm holding it with my hands. Not the best way to do it, but you know, how else am I going to do it? So anyways, there it is. I got her dialed in. It's all good, round, true, flat, whole 9 yards. I'm going to go ahead and yank the indicator out of the spindle, and I'm going to get to work on getting some new holes in this thing. And I'll get the camera set up so we can get you a view and see what I'm doing. Be back in a bit. I'd bring you in real quick here again. What I've got going on here is, you know, I'm measuring up my bolt circle, and I needed to go ahead and get in there and make sure that I've got the right numbers this time, and that I'm not going to have any mistakes or anything like that. You know, last time I should have been paying more attention than I wasn't, and I know better than that because I've been doing this for a while, and I've, you know, made stupid mistakes before by not paying attention to what I'm doing, and well, that's just what I did last time. So here's what I got going on. I needed to get my bolt circle dimension here for the back of my lathe chuck. As you can see, that's my alignment shaft that I made, and that sits right down in that chuck, and it sits in there real snug, real tight. I made it, you know, kind of like a light hand press fit, and you know, that enables me to get this thing dead on center, and at the same time it enabled me to go ahead and figure out what my bolt circle was on the back of this chuck. So what I did is I went ahead and I mic'd this diameter right here of the shaft, that outside diameter, and I come up with 1.228". Alright, so I took that and I went ahead and I mic'd my pin, and on that I've got 624, right? So I just took my 1.228 divided by 2, gives me 614, and 624 divided by 2 is 312, okay? Because what I need to do is get the radiuses, radii, whatever you want to say, radii of these two shafts, circular objects. So with that information, I can go ahead and say, all right, 614 and 312, and I write those down, okay? Now, what I've got here is my inside comparator. It's a dial indicator that you use as a comparator. Really nice tool. It's quite an old tool. It's Japanese made. Give you a little shot of it here. NCK Caliper Company, Japan. And you know, the way that it reads is in halves. Each half of the dial's 100 thousandths, and it'll measure from 3/4 to 1 3/4. So you use this kind of the same way that you would like a dial bore gauge or something. You go ahead, get yourself a micrometer set up, which what I did here, got my mic set up. You know, I went ahead and used my dial calipers there, and I got a rough estimate as to what my distance was between there and there. With my calipers, I got 705. So I said, okay. So I went ahead and I set my mic to 705, and then I took my indicator here and used my mic as the way that you would have set a gauge blocks with a dial bore gauge, and I took that indicator, set the fingers inside of there, and went ahead and zeroed my dial out on the inside of my micrometer. So took my comparator here, stuck it there in between the anvil and the barrel, and set that so that it was on 0. See if I can still get it to show you, just real quick. All right, no, anyways, I don't need to do that. So I set that up so that when my indicator was in there, I'm reading 0, okay? So on 0, I'd be 705 thousandths. I took my indicator over here, put my 2 fingers of the indicator in between, so they're rubbing on that and they're rubbing on that. Pull it back and forth, and as you're doing that, the fingers are going to open and close, and your smallest number is going to be what the actual dimension is. So with that indicator, I come up 681. So then I take the 2 radius measurements, 614, 312, add it to 681, right? And that gives me, well, you know what? I didn't do it yet, so you can see me do it right now. All right, so 681 and 614 and 312. Oh, what an idiot. I didn't put my decimal points in. All right, hang on. 681 plus 0.614 plus 0.312. All right, so there we go. We got inch 607, okay? So, inch 607. And if I were to go ahead and multiply that, that's going to give me my bolt circle. All right, 3 inch 214, 214. Okay, so there's my math. All right, I got a 3 inch 214 thousandths bolt circle, and half of that's 1 inch 607 thousandths, and that's the number I want to go off of. Right there, inch 607. That's going to be my distance from this, the center of this alignment shaft, to the center of this pin, and that's my circle on the outside of the chuck. And that's the number that I need so that I can get over here onto my rotary table and go ahead and get the right bolt circle put in there. You know, this time I really, the last video I made, I jumped in here and I was in a rush. I wanted to just get it done, get it going. I had some other stuff I had to leave and go do, so I was hurrying and filming at the same time, and you know, I screwed it up. What can I say? Everybody makes mistakes, and I am you know, not any different than anybody else. I as well make mistakes. So there we go. That's what I got going on. That's how I figured out my bolt circle there. And, you know, there's a couple other different ways you can do it, but that one made the most sense to me, and it was the quickest. Brought you guys over here to the lathe, and what I got going on here is I've got to make myself another alignment shaft. Not because the other one's wrong or it's not going to work. The other one is perfect, and I'm going to use it. This one I need, however, to set up over here in the mill, because what I had to do is go ahead and elevate my plate up off the rotary table, because I don't want to be drilling down through into this rotary table. This thing is sweet, precision ground, nice surface, you know, really beautiful piece of equipment, and I don't want to go ahead and wreck that or mess up the top of that rotary table. So this is what I got going on here. I got right here, this turned down 1 inch 228 to fit inside of my adapter plate, and then what I got to do down here on this end is I got to cut myself another Morse 3 taper so that I can take and plug this end down into the table, and this diameter is going to line up the adapter plate itself. So I'm going to try and set the camera up so that you might be able to get a view of what's going on over here. So hang tight. So I'm going to go ahead and change over to my little rough-in carbide here. Give that a shot, because this is more of my finishing tool here. I don't want to wreck the insert in it, because right now I've only got one left, and they're about $6 a piece, which $6 isn't a whole lot of money, but I don't like really just throwing my money down the drain unnecessarily. I don't want to throw my money down the drain at all, so I'd rather just use my roughing tool to go ahead and take care of this thing. And when I get down to the finishing cut, then I'll change the tool back over. And it is on center, because both tools sit at the same height in this block, so I don't need to make any adjustment. Chip now. See, all I'm doing right now is I'm just roughing this diameter down so that I can go ahead and start taking cuts to make my Morse taper. Once I start actually cutting the Morse taper, I'm going to have to pull this tailstock out of the way, turn my compound at the appropriate angle. I believe that the angle is 1.437 degrees for a Morse 3. I could be wrong there, but I'm pretty sure it's 1.4, or not 47, but 1.437. I'll look in the machinist handbook before I get back into it and start it up, but I believe that's what it is. And what I do is I just turn my compound. I set an indicator on the bed on the way, and I set an indicator over on the other side against my tool. I measure 1 inch of travel, and I measure on this indicator here to see how much of a rise I've got. Slight rise over the run, So I know that in 1 inch of travel, I believe I should have 50 thousandths and 2 tenths. Again, I could be wrong. I'm going to have to double check it. I'm going to look in the machinist handbook, see what I got. But that's how I'm going to set that up. So I'm going to go ahead and jump back in, take some more cuts, get this thing down to diameter, and when I get ready to start making the cuts for the Morse taper, I'll get some video of that too, so you guys can see what's going on with that. Alright guys, like I said, I was going to check in the machinist handbook on Morse tapers, and that's where I'm at right now. So I'm on my Morse standard taper shanks, and I want a number 3. So taper foot, 602 thou 3/10 taper per inch. I guess you could just call that, with rounding up, 50 thou and 2/10, close enough. 50 thou, 2/10, I mean, for what I'm doing right here, I could call it 50 thou and leave the 2/10 out. I'm going to use an indicator that reads into the thousandths, not into the tenths. So, I'm going to get it just right, as close as possible as I can to 50 and 2/10. But, there you have it. That's straight out of the machinist handbook right there. So, in case you're wondering, if you've got the 28th edition of this and you're wanting to check out some information on Morse tapers, there you go, page 926. Page 925's stub length tapers, but like I said, here you have it. 50 thou, 2/10, and round it up. So that's what I'm going to go with. I'm going to jump over on lathe. I'm going to get it set up so that in an inch travel I got 50 thou and 2/10 rise on my indicator. And once I get to the point where I'm going to take a cut, we'll show you that. Be back. Setup. This is for doing the Morse 3 taper. I got my compound turned, and as I showed you just earlier, You know, it figures out to be 50 thousandths and roughly 2/10 taper per inch, right? So here we go. We're back over the lathe, and I'm just going to show you real quick how I do this. You know, I got my mag base set up on the tailstock of the lathe, and as you can see here, you know, there's my my indicator that I got sitting on the compound pressed. Okay, now that's zeroed out, and what I got over here is another dial indicator that's resting up against the carriage. So that's also zeroed out. So what I'm going to do is I'm going to go ahead and rotate this indicator around 10 times. I'm going to travel the distance of 1 inch, and I'll come back up, look at my indicator there, and that's going to tell me, you know, the rise overrun. I'm holding the camera in my hand, so I'm going to wind this around with one hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's 10. All right, so we're sitting on 0. All right, so I'm going to come up, and you know, there we go. There's my indicator, and I'm just past the 50 thousandths line. You know, you give you a little bit better view there. That's probably in the neighborhood of 1 to 2/10 right there. So, you know, I'm right on. I'm right on where I need to be. Okay, and that's how I do it. Sure, there's different ways. That's how I like doing it. You know, you watch YouTube out there, there's probably, you know, 5, 6, 7, 8 different ways of doing it. You know, if I stood here for a couple minutes, I could come up with a few more myself, but that's a quick, easy, here and there and done method. And, you know, figured I'd just throw that in the video so you guys can check it out. And yeah, that's that. So I'm going to go ahead and pull my indicators off. I'm going to get my tool block lined up square with my part on the face of the jaw, on the face of the lathe chuck here. And yes, I am using a 3-jaw. I do have a 4-jaw. I'm using the 3-jaw. I didn't just throw it in there and chuck it up. You know, I went ahead and put my part in, and I indicated off of my other surface right here that I had turned prior to me flipping it end for end here. So I indicated off this, and I got it running in within less than a 1/2 thousandth, you know. So my length of my part here, I'm not going to have run out from this end to that end. It's not going to vary. I know I'm good, and you know, I set my indicator on there, and I just use this soft face hammer, just tap 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 tap, keep spinning around. You know, just give it a couple knocks here and there, and you get it lined up, you get it running in true. Go ahead and tighten it down, and you know, you're good to go. All right, so I'm going to set the camera up, and I'm going to get this stuff out of the way, and I'm going to go ahead and set up my tool block, and I'm going to start cutting that Morse taper. And be back shortly here. Well, here we go. I'm going to jump on in and start taking some cuts on this thing. Start trying to get my Morse taper going. You know, I hope you guys got a decent camera angle over here. I'm not gonna sit and take footage of the entire thing. I'm just gonna do a few passes on here. I don't really have a place to set the camera right now to get a good shot. Eventually, shortly here, what I'm gonna do is get some magnetic feet. Well, really, what I'm gonna do is get some little disc magnets and epoxy them to the bottom of my tripod. So I can go ahead and set the camera right here on this tailstock. And, you know, that'll give a good vantage point of what's going on here with the work. But for the moment, you know, this is what I've got. And I'm going to go with that. All right, so here we go. That's 100 thousandths on the diameter. There goes another 50 thou pass, 100 thou on diameter. And I'm okay with doing this without the tailstop because I'm not coming across this way on it. I don't have a whole lot of sideways pressure. I'm putting downward pressure on it. And you know, I'm feeding my hand here. I'm just kind of going real slow. Not worried about popping this thing out of the jaws. I got a real good hold on it. Tightening it real nice and tight. The engine material's drawn all the way up into the chuck. You know, so I'm not worried about any of that. If I were doing any other kind of cutting or whatever, you know, I can't use the tailstock because obviously the tailstock is going to come up and it's going to hit my compound right here. So a lot of you guys out there know about that. But, this type of work here where you're cutting tapers with your compound, you know, sometimes you just can't, depending on what your angle is, sometimes you just can't use the tailstock or whatever. That's how you got to do it. So I'll bring you in, get a little bit better, closer look here. Let me zoom you back out. All right. So, you know, there we go. That's what I got. Small end on a Morse 3, I believe is supposed to be 798. Of course, don't hold me to that. I'm not looking at the book right now. You know, so I'm just kind of throwing that number out there. Like I said, I believe it's supposed to be 798. I'm going to go over and check it. Actually, hang right on. We're going to take a look. All right, guys. So here we go. I'm at the machinist handbook again, and you know, I was off. I said 798 Morse 3. It's 778 on the small end, 938 on the big end. You got 3 7/8 length overall. All right. So those are the figures I'm going by right there, Machinery's Handbook. And it's kind of like the machining Bible. You live by that thing when you're a machinist. Hey guys, how we doing? So I'm gonna have to go ahead and end this video, and I'm gonna just call it a night here and take off, and I'll be back tomorrow, and I'm going to jump back on getting to work on that plate, those parts, getting going on that. I've got the alignment tool and the alignment shaft made with the Morse tapers on them, and I'm going to go ahead and get on the mill and get back to work on it. So I'll put up this video, and next time I put a video up, which will be real soon, it's going to be of me over there on the mill working on that plate and see if we can get her done. After I get the plate straightened out, what I'm going to do is I'm going to go ahead and make the mounting blocks for the cam bolts. And when I get to that, well, I mean, I'll show you the whole process. I'll show you that too. All right? So, we'll see you soon.